This is the 30th edition. Like, we have successfully conducted 29 such webinars every Saturday, 4 to 5, as an outreach initiative.
Yeah.
And we are
Actually, I have
so
seen that one since number 30 has been written. Then that time I came to know that in every week might be it is going on.
yes, sir. Actually, our exams are also going on.
Yeah.
Uh,
And this is the time of mid semesters.
Sir, we are running a little late, we can say, in the sense like we will be not having summer vacation, so we'll make up that gap. But right now, exams are just concluding.
Yeah.
So, like, not many may be able to turn up, but we have a YouTube link which is again shared with students.
Okay.
So, it also serves as an archive for us. Lakshminath sir, I think we can start. Students will join. Um
Okay, ma'am, should we start?
yes, sir. Students will join. Let us start.
Okay, ma'am. So, very good afternoon, one and all. I, Dr. Lakshminath Tripathi, Assistant Professor, Computer Science and Engineering, on behalf of CSE Department, I welcome you all to this weekly academic lecture, Series 30. So, it is our pleasure to welcome to our Chief Speaker, Dr. Jayakrushna Sahoo, IIIT Kottayam, Kerala. And this is time to give introduction about our speaker. So today's speaker is Dr. Jayakrushna Sahoo. He has received PhD degree from IIT Kottayam and MTech from IIIT Bhubaneswar, and he is currently working as assistant professor in Department of Computer Science Engineering, IIIT Kottayam. And before joining this institute, previously he was working in NIT Jamshedpur and NIT Jamshedpur and BML Munjal University, Haryana. And he has many research paper into his credit. like expert system and other. Now, I request Dr. Jayakrushna sir to start his presentation.
Yeah, thank you for the introduction. So without any time delay, let me share my slide. So my slides are visible.
Yes, sir.
It is visible.
So in today's talk, we'll go for evolution of machine learning and how federated learning has discovered, generated, means how it is coined and everything. So what we'll do, we first start with the evolution of machine learning and end with what is the future perspective of federated learning. So initially, we'll few discussions we'll do for evolution of machine learning and the time frame, and then we'll go for the taxonomy for the components of the presentation and the semantic model building using ML. Then we'll see how cyber physical system now dominated the internet and or you can say the whole society. And we'll go for then see the federated learning and what is the training process, its challenges, and its future directions. So let's start from the beginning, evolution of machine learning. Even though a computer has been discovered so many years before, the evolution happened of from Turing machine, or you can say Turing machines to current very high intelligent robotics, or you can say vehicles, okay, means intelligent vehicles, and many more AI devices. Okay, so the technology being increases day by day, and it starts from Turing test to current scenario. But whatever may be the applications now of machine learning, it is also very difficult to judge from where it starts and how much it will go beyond. But the results and its applicability is clearly visible to all of us. Let us say this from here, even though neural networks, the foundations have been started at 1943, then Alan Turing proposed the Turing testing to test a computer's intelligence. So as we know that it is done by from behaviorism, means asking a series of questions and answers, and then decided that the computer has intelligence or not. And proceed with that. In 1952, that Arthur Samuel of IBM developed that computer program that playing checkers, okay, in 1952. So in here, just only that side that how the computer will win the game, and based upon that some minimax strategy to win the game was done here, and slowly developing in some conferences in 1955, the term AI is coined because since that learning paradigm already discovered. Slowly moving to that, even though in 1943 neural networks has been developed, but in 1957 by 1957 that the first neural network for computer, means that Hepes model is created by Frank Rosenblatt. What happens after this? That means that what we know as the perceptron after 1957, then slowly many algorithms, many neural network, Adeline, Madeline, and everything is taken to picture into 1959, the term ML is coined. Okay. So slowly moving that one on 65, the expert system was introduced in 1965 by a Stanford heuristic programming project led by Edward Hengenbaum. Okay. Then sometimes he is termed as the father of expert system. Then slowly in 1967, the nearest neighborhood algorithm was conceived, which is the basic program for pattern recognition. This algorithm was used for mapping routes and was one of the earliest algorithm to finding the solution of some traveling salesman problem for finding most efficient routes. But the point is here, the traditional traveling salesman problem, they have used some nearest neighborhood algorithm here. Then means designing the nearest neighborhood rule. Then slowly going on improvement on 1979, that it is actually 70s, the mobile robot, or I can say remote controlled vehicle has been introduced. What is known as a big truck, which is a programmable electric vehicle, and which is possible to use for moon or some planet-old style environment. So here that once that mobile robot has been invented, slowly many improvements has been done on AI. And through expert system, means a decision-making system, and that although in 1965 it has been created, but it is prolifted to in 1980 for expert system is proliferated. So here that the some universities and many organizations starts courses on expert system and offered many courses, and some companies and they have investigated in the projects of expert system for their business activities. And so as that stands for fifth generation of computer systems. And then slowly on 1981, that logic-based learning, in particular to area of AI, defined. And that is nothing but the intersection between knowledge representation and machine learning. That involves the automated construction of logic-based programming from examples with the use of domain knowledge. So through this, there's some inductive logic programming is useful in particular to bioinformatics or natural language processing. And that time also that a prologue program also introduced in those areas, in those years. Then in 1985, the fast speech recognition system that only understood the digits is introduced. Means although so many years before of 1985, in particular to 1952, in 50s, some speech recognition techniques is there, but this is converted to a automated speech recognition technique in 1985. And slowly, from in 1990, we have that knowledge data analysis is going to data-driven, knowledge-driven transfer to data-driven analysis. In 2006, as you know, all of us, that deep learning has been comes to means it becomes more famous among the technicians and engineers. In 2009, based on deep learning, that self-driving car is made by the Google. Also, after that, in 2010, that quantum computing is integrated with machine learning, So many papers on 2013, 14, and everything you can find on quantum machine learning. And the pioneer paper, the generative adversarial networks, comes in 2015. That is a powerful class of neural networks that are used for unsupervised learning, and it was developed by Godfellow, obviously in 2014. Initially, it was basically made of a system of two competing neural networks, which compete each other and are able to analyze, capture, and copy the variations within a data set. Then in 2006, that Google framed that term federated learning, because although so many machine learnings can be implemented in various aspects, we'll see in a few slides. In 2016, that Google terms federated learning. And so after that, many things have been discovered, but that is nothing but the hype of AI. Many startups have been built, and many courses have been in the universities. Many degrees, in particular to various individual courses also, has been going nowadays. So this way, even that machine learning plays a subset, that which we call subset of AI, starts from the Turing test to the current scenario. So moving to what taxonomy of how all of you know these things. So that machine learning, that what is so it is a subset of artificial intelligence that applies algorithms to extract patterns by using mathematics, statistics, optimization, ontology, knowledge-based knowledge discovery methods. Sorry. So this machine learning, you can classify to unsupervised, supervised, and reinforcement learning. Supervised learning is most well known in machine learning process tasks that aims to find out the relation between the set of inputs and with the set of outputs. What that makes the system, that makes the training to the system. That mapping function defined from input to output, that should be best estimate the output at the end of the training process. And this type of supervised learning can be used for forecasting or predictive modeling. Such type problems can be as regression and classification. Okay, so it depends upon you have categorical data, then you go for classification. You have continuous data for the target variable, you are going for regression. Then it comes to the unsupervised learning. Here, just like in supervised learning, we have mixed with the target variables, and this unsupervised learning can be categorized to clustering, many parts of the clustering, associative discovery, dimension reduction. And in reinforcement learning, we used to address that Markov decision process, that agent, and with some rewards to gain some optimal policy through interaction with the environment. So it focuses on to gain a maximum reward for an agent by some actions in the environment, by doing some actions in the environment. So what happens in machine learning, whatever may be the setup, whenever we have a training data here, then we train the machine learning algorithms. Then we'll see input data, we have to model it. Then for new input data, we check what is the ML algorithm and take the predictions. And then we'll see that it is a successful model or not. If not, again, we'll repeat the process. So whatever may be the environment setup, we see various algorithms and services are managed between the actual source of data and the learning platform. This learning platform where the ML algorithm learn, ML algorithm will implement, that can be a server or can be a cloud. So depending upon the availability of resources, your ML algorithm can be modeled as centralized or decentralized. Or sorry, not decentralized, centralized, or in a distributed fashion also, or parallel algorithms also. So, but what the current scenario is, so in the literatures of healthcare, we find so many machine learning algorithms are applied, and their distribution is like this. So whatever may be the depending upon the supervised and unsupervised reinforcement learning, that support vector machine neural network, logistic regression, discriminant analysis, random forest, linear regression, naive Bayes, nearest neighborhood, decision tree, hidden markup, and others also there. So this is the how machine learning, and most of that you see that support vector machine is used more in particular to healthcare and also in bioinformatics. So how these algorithms actually executed, what I did tell you just now. You have to execute the training data to the model with the model. So the data, whatever data you have to share with the server. Then server can run the algorithm and give you the output. But now the scenario has been changed because of this cyber physical systems. So since it is a very complex engineering systems, which is based that is on the integration of your physical and computation and communication parts, everything is integrated. And the operations, whatever performed in the cyberspace, need to be controlled, coordinated, also monitored, and integrated by computing and communication core, which is the integrated with your physical environment. So it has different applicability found in different areas. For example, in healthcare, in smart transport, in data centers, smart buildings, smart homes, power grids, also in safety support system. Okay. So the main point is you have to address the issues of system dependability, efficiency, and security. Although we have seen that in this cyberspace, you have to monitor the physical world events, and high-speed communication is necessary using either wired or wireless network technology. And in computing part, you have big data analytics and everything. And on AI, you can apply machine learning, those kind of things. But as we see, its application depends upon domain, starts from aerospace to healthcare, smart building, everything. There are many devices. If you get smart building or smart home, there are small IoT devices which have limited capacity. So if you going to train some model such that the physical world with accumulated with the network resources to the computational resources, that means it is a closed loop actually. The physical world you have to sensing to cyber world, and then you have to do the actuation. So in this loop, whenever some smart devices will be connected, that should be smart enough to monitor or to detect or to recognize the things. And ML algorithms are better for that. And particularly all the whatever the classification face recognition algorithms, that belongs to AI and machine learning. And the main part of this one is that the devices, the number of devices increases rapidly. Every individual nowadays have at least 1 or 2 mobile phones, minimum 3, or laptops. So many gadgets people are using. So the number of devices increases. So since the number of devices increases, so what is happening now? As we see, billions of phones and IoT devices and constantly generated data, since many devices, more than 2 billion or 4 billion, like that. And since in data-driven approach, that will be enables for your better products and smarter models. Okay, so whenever you will see that how many devices Google used, you see the 2.5 billion Android power devices worldwide nowadays, today's date. Okay, it is on 18 January 2022, in which 1.5 billion devices are Gmail users. So Google many mobile that Google has many mobile users that uses the Androids. So the data might be more. So these billions of phones and other gadgets generate constantly huge amount of data, but these data sets are a lack of these are low power devices, you can say, because whenever you send the entire data to a server, your battery power, network consumption, everything will be comes to picture. So it is not possible that every time that you can send the data to the server to launch some AI algorithms. At the same time also, whenever you are sharing the data, you are losing your privacy. So there are many organizations or many institutions. They are interested. They want to apply machine learning algorithms, but they don't want to share their data. So where the concept of federated learning comes to picture. This is an emerging concept, and what happens that training happens in a very decentralized manner, where many devices performing collaborative operations. Those operations is centrally controlled by the server. Okay, so now just remember that whenever that this learning is happening, what is the advantage? Why we are doing for federated learning? Because that personalized, okay, whatever the data you have in your device and whatever you are training, whatever the app is built for you, that is fully personalized. For example, you can take your Google keyboard, Android keyboard. Okay, whatever you type, it will give suggestions as per your previously sentences. Low cloud overheads, infra overheads, minimum latency, and obviously privacy preserving. So for these reasons, we are going to need federated learning. So here, that suppose this is there are, as I told you, that learning performs at the client devices, but it is monitored by and controlled and managed by the server. So the peculiarity of such setup is that the training data remains decentralized. That means the training happens at the location of the data and not the other way around, just in your traditional machine learning approaches. This methodology, this FL, what it gives, suddenly it reduces that collection of and data minimizations and leveraging some privacy risks. Although this formal federated learning proposal was made by Google, it described as it is a distributed machine learning paradigm that uses interaction between multiple mobile devices, okay, or you can say smart devices. So here, so our this aggregation model, this is a centralized model. So our centralized machine learning application, what is here, we'll have a local copy on all devices. So what is the model? That local copy will be here and here and here. And where these users can use as per their need and with the local data. And the model will then the model parameters will again send back to the that central server, and it will collect all the parameters. Then it will do the aggregation here. Then the updated information it will pass to each client. Then within that, again the model will run here to means for a better training. And at some time when the better accuracy result will come, that time the model will stop learning. So when it updates its central, when the centralized server update its central machine learning model from the aggregated results, that is far better than the previously deployed versions. Now, the FL process, that means the updated parameter means the new version is used by the in these models, smarter models. But it has not only unlimited to mobile devices. It has some silos also in medical applications or in any. For example, this is a hospital. This is some insurance company. This is some pathology, and this is some pharmaceutical things. Okay. So they have they have some data related to some applications, but they don't want to share their data. So here the central server will aggregate the model. It will give initially it will run a model with some temporary data. Then it will give that model to each client. Then they will run that model in their local server. After that, they will give the updated weights. They will not send their data. Okay, they are only sending the model to the centralized model, central server. The central server will aggregate, and the newly updated parameters it will send to again each client. Okay, and the process will continue. So in general, the Federated training process for a depends upon your particular applications, and the server which initiates the training process, it has to repeat these steps. Initially, it is for client selection, then broadcast, then client computation, then aggregation, then model update. On client selection, the server samples from a set of clients that will satisfy the eligibility requirements. For example, mobile phones might only check into the server if they are plugged in, okay? And if they are not selected, if they are ideal or they are switched off like that, if they don't wish to participate. Then the selected client will download the current model weights and the training program from the server. Using that downloaded model and the training program, each client, that means the selected devices, locally computes an update to the model by executing the training program here with their local data and sends the updated weight to the server. The server collects all the updates and aggregate it. Remember here some aggregation will be done here, okay? And for efficiency, different strategies can be followed for this aggregation. Once this is the updated, after aggregation, the model will update and again it will repeat to the client selection. So like that, this process, training process will follow. And when that model is up to accurate, then the training process will stop. So in short, the life cycle of this FL might be something, but in a higher level, it starts from problem definition to the deployment. In problem definition, the model engineer has to identify the problem to be solved with federated learning. Once you identify the problem, then you have to form the client instrumentations if needed. The clients, that means you can think the app in your mobile, okay? For example, Android keyboard, Gboard you can say. Suppose you are the problem is predicting the next word, okay, when you are typing. So that if needed, the client are instrumented to store locally the training data. In many cases, actually, the client will store its local data, particularly the apps. For example, your text messaging app store the text data, or photo management app already store some photos like this. However, in some cases might be some additional data or metadata might needed, and that to be made by user interaction, okay, for the supervised learning task. And then the model engineer may prototype a model, architect, and test learning hyperparameters, okay, using some proxy data set in the server. Some prototype you have to create, okay. For example, suppose you are creating for your logistic regression. So some data you have to, proxy data you have to generate, and based upon that you create a logistic regression and the parameters you have to send to the client. Now starts with the federated model training. Multiple federated learning tasks are started to train different variations of the model and use different optimization parameters because there are many clients. So now in model evaluation, so when the task is trained sufficiently, the models are analyzed and good candidates selected. For analysis, you may use the standard metrics. Then, once the model evaluation is over, that the model deployment is similar to machine learning deployment models. If the model is once is good enough, Then you have to start the launch process, means the model will be deployed in the client device. So this is the life cycle of a federated learning. So comes to the, when you see the model development, that means how this machine learning is, how this federated learning will be implemented. Depending upon that, depending upon the distribution of, since the distribution of data set is unknown to the central server, based upon the different distribution in the sample space, you can say feature space, it can be divided into horizontal federated learning, vertical federated learning, and federated transfer learning. And remember, whatever this data is on the client side. Server does not know about any data. Okay. In horizontal federated learning, is to split the data set horizontally. You have to split the data set horizontal, then take out the part of the data that the user features are the same, but users are not exactly the same for training. In other words, data in a different rows have the same data features. Okay. So in the row side, you have same data features, different rows. For example, suppose there are two provider of for an insurance company of two different regions, whose user groups from their respective regions. Okay, so for example, that one insurance company has provided the data from the Delhi, another one from here, Bhubaneswar. So they have some different user groups, but their features might be a little overlap to each other. Since their business is similar, they have same insurance company, their features. That means the user features of the records are almost same. So in that case, you can use horizontal federated learning to train a model. And in case of vertical federated learning, this learning is available in that when the user features of two data sets overlap little, but users overlap a lot. In the previous case here, users are not overlapped, their features are overlapped. But here, users are overlapped, their features may not be overlapped. For example, there are two, suppose one is a hospital, another one is a insurance company. Okay. For hospital, might be users are same, but their features are different. Similar, the insurance company uses different features for a particular user. So in this case, users are same, but their features are different. So that time we may go for vertical federated learning. And in case of federated transfer learning, the two data sets are rarely they are overlap. No need of doing segments on data, but you can use transfer learning to overcome some data lags. And then, so where can be federated learning can be used? So you can use for enhancing your natural language processing models in robotic process automation solutions by using multiple data from different enterprises, improving the accuracy of fraud detection models using data from credit card companies and banks. So once you are saying that you are collecting data from credit card companies, you are not actually collecting the data from the credit card companies. You are only giving the models to run in their system and in their banks also. You are not taking the data. Enhancing personalization and recommendation system using data from different consumer enterprises. In healthcare diagnosis, you have to use computer vision models from data from multiple hospitals. So when you are avoiding to migrate databases into centralized locations. Then, so in a nutshell, you are learning that your learning algorithm will implement it on the client's side in the client's machine, but not in the server machine. So, but still, there are some applications. There are few applications, just like mentioned, such a Google keyboard. If you give some word, it will give few suggestions that learning is based on your local device. So this is the first applications used by Google, that Android keyboard. So this is done without using users' data to the Google server. Similarly, you can see Apple phone for that voice recognition, Siri. And in the healthcare industry, you have seen that in the last 2 years, the country has suffered from, not country, the entire world has suffered from the COVID pandemic. But what happens, the lack of resources in the healthcare industry is a main issue here. So the healthcare professionals need a reliable technology that should help them to treat the patient better. But they need an algorithm that will detect or recognize or identify whatever it may be, but they are not interested to share their data because of some data privacy regulations of street regulations, government regulations are there, so data cannot be shared, or company regulations is there. So this is where FL is coming to picture. So the participating institutions train the same algorithm on their local dataset, in-house data pool, you can say. And then they will enjoy this trained algorithm. And in fintech companies, in finance and technology organizations, sometimes it happens that trust business and the consumers, they have to trust each other to keep the data safe, of users' data safe and secure. But if you use the traditional machine learning algorithms, there are several issues, include getting clearance and lawful consent, as well as the preservation of the data, and the time and cost in collecting and transferring data across the entire networks. So, but here FL provides a simple solution. So you keep data local, and you use edge devices and edge computing power. That means you can use some encrypted and distributed machine learning approach here. Similarly, in insurance sector, suppose there are many product and activities often occur. Suppose there one insurer violates the insurance company's trust by making some false alarms or false claims. Okay, making some false claims. He violates the insurance company's trust. The individual or business can be accountable for any type of fraud and illicit activities But insurance companies, they have considerable amount of data from different type of insurance agencies. For example, a health insurance, life insurance, car insurance, okay. So to mobile insurance, okay, any small device also nowadays insurance is coming. So their insurer may associate with various other companies. So when they associate, they will not share the data, but they will learn the algorithm there to identify if individual is a fraud or not. So without violating the data clause, and the organization or the company or the insurance company could identify its user's pattern, and hence it leads to the fraud and data prevention. And in OLS communication in IoT, since many organizations have started to train their algorithms on various data sets collected from various sensors, okay, and they are communicating through various network data. So here, if you data sent through a wireless communication network, that latency cost will be increases. So let the data, keep the data in the local machine and do the learning. So federated learning also comes into picture here. So when you are going to apply the federated learning, when you are going to apply in some applications, then make sure your data is distributed across the silos or across the devices, edge devices. And make sure the data is confidential and cannot be shared. And the data is potentially owned by different organizations or individuals. So you cannot access the data. But since you are applying a model, a learning, and you are aggregating, so data should have some similar nature. So they have same type of objects, either users or features. Okay, some should be mapped there, otherwise the learning will be difficult. What are the challenges you will face? Obviously, privacy protection, even though privacy, people are thinking that privacy happens in data is not shared. But once data is, device identification is there, the server may know the device who sent the data. So sometimes the app or the client can send sensitive information to a third party. For example, whenever you are sending some, when the local model will send the parameters to a global model, sometimes device ID can be sent along with the data, along with the model, along with the update model. So there is some challenge. So many works has been going on how to privacy protection in federated learning. Communication cost also a key bottleneck. Since federated learning consists of various devices and millions of remote mobile devices, so this training them and with the involvement, large amount of communication needed. So how to make this communication efficiently also is a challenge. System heterogeneity also there, because different devices, okay, different networks. So how to tolerate this FL, how FL will tolerate this heterogeneous hardware, and it will be robust to online devices as well as to the offline devices in the network. So there are very research when it shows that FL, that federated learning, that mobile nodes may mislead the server because if a node is moving, it may mislead the servers in which case to update the global model in aggregation intentionally or unintentionally. Okay. So sometimes this may be some malicious behavior. So how FL will resist this type of unreliable model. Okay, local model upload. So that is also a challenge. And in some future directions, improving the efficiency and effectiveness, privacy restrictions, extreme communication scheme, multi-center felt learning, reliable client selection, all just challenges has been converted to future directions. For example, in multi-center felt learning, here that heterogeneity comes to picture. So if the device information heterogeneity will be obtained in advance, then the mobile devices can be grouped as per their heterogeneity. So this starting multi-centered federated learning to solve heterogeneous challenges obviously is a promising research. Similarly, a reliable federated client selection, defending against some attacks, malicious attacks, and extreme communication schemes. These are some of the future directions of FL. So these are the references. The main reference is the last one, a survey on federated learning knowledge-based systems. Yeah. So thank you.
Thank you, Jayakrushna sir. Have any query? Anybody have any query can ask. As there is no query, so we can conclude our session with a vote of thanks. I request Madhuri ma'am, can you give vote of thanks and conclude our session?
Sir, I am really very thankful to you for giving us this time and telling us about federated learning. The session was so useful because machine learning we all talk about, and you have shown us how data privacy is also uh, to be is something that we need to also think of, and the federated learning is actually talking about it. So you actually put us to think about it, and you also showed us some research possibilities. Thank you so much, sir, for giving your time, and we really look forward for any possible collaboration in future. Because our students might be interested. I have noticed some of our PhD scholars also here. So the webinar actually has been also available on the YouTube link. So we'll share it with our students. And if there are any doubts, sir, we'll connect to you, sir. Thank you so much, sir.
Madam, can you switch on video and take a photo? All of you can switch on video
Sure.
and take photo.
Sir.
Okay. So I request Jayakrushna sir can switch on your video. Okay. Thank you.
Sir. Sir, and on behalf of the organizing team, I would like to thank Lakshminath sir for getting us such a nice and wonderful speaker. I would also like to thank our HOD madam, who is the convener of the webinar series, our Sarda Prasanna Pati sir, who without him we cannot actually do anything much out here. I also would like to thank our participants, Divya Sundar sir, Bharat sir, for being there in the organizing part of it, and all the participants who have given their time to listen during their exams. Actually, thank you so much, sir.
Thank you, ma'am. Thank you, ma'am. Actually, you have been in touch with me since last 15 days and giving you update in every day. Okay, thank you, madam, for your constant support.
Thank you, sir.
Okay.
Thank you, sir.
Thank you. Thank you.
Jayakrushna, sir, we'll be in touch with you, sir.
Sure, ma'am.
Sir, thank you so
Thank you,
much.
Jayakrushna.
Yeah, thank you. So, may I leave?
Yes, sir. Thank you, sir.
Thank you.
Sir, have a nice weekend. So.